and welcome to this video on annuities. An annuity is a series of payments, usually in equal amounts, made at regular intervals for a fixed period of time. Consider the example we have right here. We have that since the birth of his daughter, 18 years ago, Bradley has deposited $190 at the beginning of every month into an RESP. The interest rate on the plan was 4.70% compounded monthly for the first 9 years and 6.40% compounded monthly for the next 9 years. First, we want to calculate the values of the fund today, the value of the fund today. Second, we want to know how much of this fund is the interest. So to work with a problem like the one we have right here, we need to understand that annuities are very important, and they come in different types. What is being described in the statement is a couple of annuities. So here, really what we have is that the deposits form two different annuities. We have an 18-year period, but that period consists of two separate periods. And we have two different annuities because when the payment amount, the interest rate, the payment period, or compounding period changes, a new annuity is formed. In our example, the interest rate is changing from 4.70% to 6.40%. Then we have two separate annuities. So let's call the first annuity annuity 1 and the second annuity annuity number 2. Now we have that for annuity 1, payments are made at the beginning of each payment period. Payment period is monthly. So we have monthly payments that are made at the beginning. And we have that the amount of the periodic payment of the annuity is $190. So PMT is $190. Now, the total number of payments during the 9 years equals, let's see, we have 9 years multiplied by 12 payments that are made in a year because payments are made monthly. So we have 108 as the total number of payments during the term of the annuity. Here the nominal interest rate is 4.70% or 0.047. And the compounding frequency is 12 because interest is compounded monthly. So what we can say is that for the first annuity, the corresponding periodic interest rate is 0.047 divided by 12. And that gives us the number 0.0039 and some other digits. Okay. Now, because payments are made at the beginning of every month, of each month, what we have here with annuity 1 is an annuity due. And this annuity due is a simple annuity due because the compounding period and the payment period are the same. Notice that the payment period is monthly and the compounding period is monthly as well. So A1 is a simple annuity due. So let's write the classification here. We have a simple annuity due with all the characteristics right here. Now, in a very similar way, we can say that A2, the annuity number 2, that comes from considering the regular payments after the 9th year and up to the 18th year, is a simple annuity due because payments are made at the beginning of every month and the compounding period and the payment period are the same. And for the second annuity, we have that the payment period is still monthly. The amount of the periodic payment is still $190. The total number of payments during the term of the annuity is still 108 because during the 9 years, every year 12 payments are made, so we have 108 payments in total. But here the nominal interest rate is different. We have 6.4%, or same thing, 0.064. Here the compounding frequency is 12 because the number of compounding periods per year is 12. Interest is compounded monthly. So we have that the periodic interest rate is 0.064 divided by 12. And when we compute that value, we obtain the number 0.005333 and more digits. So here we have all the information we need to work with the second annuity. Here we have all the information we need to work with the first annuity. Okay. Now, the first annuity is a simple annuity due, as we said. And there are certain formulas that apply when we work with a simple annuity due. When we have a simple annuity due, then the future value is computed by doing PMT. So we multiply the amount of the periodic payment by 1 plus I to the n minus 1 over I, and then all that times 1 plus I. So what we're going to do to answer part A of this problem is we're going to find the future value of the first annuity. Then we're going to find the future value of the second annuity. And then we take the future value of the first annuity and compute its future value because, once we have the future value of the first annuity, the interest is calculated for 9 more years. And we're going to take that future value of the first annuity and add it with the future value of the second annuity, and that will be the answer. So let's do that. So I'm going to erase right here. Let's erase what we have here. There you go. And let's work with the first annuity. So annuity 1. Okay. So for the first 9 years with an interest rate of 4.7% compounded monthly, remember that we have n equals 108, I equals 0.003917, and so on. Then we have, and remember that the amount of the periodic payment is $190. Then we have that the future value of that annuity is $190 multiplied by 1 plus 0.003917, etc., to the 108 minus 1 over I, and I is 0.003917, etc. And then times 1 plus 0.003917, etc. And when we compute this expression, we find the number 25,581.16. And we round off the answer to 2 decimal places. But we would like to find a future value of this accumulated value calculated above at the end of the 18-year period. Therefore, we need to find a future value of those $25,581.16 in the second part of the term using the interest rate of 6.40% compounded monthly. So the future value of that future value we just found is computed by doing $25,581.16 that accumulate some interest for the 9 years that follow. So we have 1 plus, and we divide 0.0064 by 12. So we get this, and then for the following 108 months, the future value of that amount will be $45,436.94, 32, 76, etc. dollars. Okay. So we're working on part A of the problem. Right now we're working on the first annuity, the one corresponding to the first 9 years. The annuity, the future value of the annuity is given by this expression right here. We have $25,581.16, but then 9 more years have to pass, so we need to find a future value of that accumulated value at the end of the 18-year period. So we need to find the future value of $25,581.16 in the second part of the term using the interest rate that applies to the second part of the term. Okay, let's keep this number in mind. The number right here is important. To find the second annuity, the value of the second annuity, remember that n doesn't change. Now I is about 0.00. I wrote those values before, so I'm not going to write them again, like where they come from, but I just write, just a moment, we have this. Oh, it actually changes a little bit. Remember that this was changing. We had 5, 3, 3, 3, etc. Right, that looks better. The amount of the periodic payment is the same, $190 every month at the beginning of each month. So the future value is $190 multiplied by 1 plus 0.005, 3, 3, 3, etc. to the 108 minus 1 over 0.00533, etc. multiplied by 1 plus 0.00533, etc. And what we find here is the following expression. We find 27,799.169706, etc. There we have the value of the future value of a second annuity. Okay. Now the total accumulated value of the fund at the end of the 18-year term is the addition of those two numbers that we have right here. So let me erase this formula and get to the answer to part A. So the answer to part A comes from adding the future value of annuity 1 and the future value of annuity number 2. So we do 45,436.94, 3276, etc., plus 27,799.169706, etc. And when we round the answer off to 2 decimal places, we get the value 73,236.11. So that's the answer to part A of this problem. Okay. Now we can move on to part B. So I'm working on part B. Next, we wonder how much of that is interest. And to compute the interest, we do future value minus what was invested. So we do future value minus n times the amount that was deposited. So in this case, we do 73,236.11 take away, and there were 108 payments for the first 9 years, 108 for the second 9 years. So that's 216 payments in total of $190 each. And when we compute that subtraction, we find $32,196.11. So the interest was right here, the $32,196.11. Okay, so that's it for this problem. Remember that we found that we were working with 2 separate annuities because the interest rate changed. Also, because we were working with 2 separate annuities, we had to find future values of those annuities separately. And then with the first annuity, because the future value of the annuity was what that annuity was worth after 9 years, and there were 9 more years that had to pass, and we had to find the future value of the annuity. And then for the second annuity, at the end of the 9-year period, the future value of that annuity was found using the formula that we use, that tells us that future value of a simple annuity due is the value of the periodic payments times 1 plus I to the n minus 1 over I, and then times 1 plus I. Alright, if you have questions, please write a comment or contact me and I'll be happy to help you. Thank you for watching this video. Bye bye.